Hello everyone, welcome to Code Guy channel. This is video about how to implement the Tower of Hanoi algorithm. In this task we need to define function Hanoi solver. This function will take a number of disks as a parameter and return string with all the moves taken to solve this puzzle. Let's define function Hanoi solver that takes parameter number of disks. I will define three variables, our routes 1, 2 and 3. Route 2 and 3 will be empty lists, and route number 1 we will populate with disks. We will return disk variable for disk in range. The range function will take three parameters: start, end and step. Start will be number of disks and 0, and the step will be -1. It will allow us to put our numbers in reverse order from biggest value to smallest. Then we will create getListString function that will return the string route 1, route 2, route 3 and breaking line character. Like in the picture example where we're supposed to pass 3 as a number of the disks, then we build a first row that is representing as a list 3, 2, 1, then empty list, then empty list. Let's create function moveDisk that will take two parameters, start and target. Start, it is where disks currently are. Target, it is where they should go. First of all, we need to check if we have any disks to move. If not, start, return. If there is any disk, then target, append, start, pop. In our first route, the smallest disk is always in the end of the list. That's why we're using pop method. Let's go to the hardest part of the algorithm, the function moveTower. This function will take four parameters: start and target, accelerate, temporary storage, and n, number of disks to move. If there is only one disk to move, then we call function moveTheDisk, start and target, and return getListString. If there is more than one disk to move, then we have to make several recursive calls. First of all, we will define variable result where we will be concatenating all the getListString function calls. Then we will create the first recursive call. We will call moveTower function, but we will switch some of the parameters. First parameter will be start, second accelerate, third target, and we'll need to take one from the n. N, it is number of disks. We switched accelerate and target because we need to move the smallest stack to the accelerate route. And now the largest remaining disk can move safely. We call moveDisk function with start and target. After this, we are concatenating to result getListString function. Second recursion. We need to move the smallest stack from the accelerate route into the largest disk. This time we are calling function moveTower, accelerate, target, start, and -1. And in the end we are returning the result. If it is hard to understand, look on the picture example again with animation of the disks and routes. First recursive call, it is for the smallest disk. The second recursive call, it is for larger one. We will define one more variable, return string. That will be a result of calling getListString. This way we will save initial state every time when we are calling the function. And the last step, if number of disks more than 0, then return string, concatenate moveTower, route 1, route 3, route 2, number of disks. Move all the disks from route 1 to route 3 using route 2. Return string, trip. As you remember, getListString will create extra space in the very end, a new line. We need to remove it with the trip function. Our algorithm is complete. Thank you for watching. See you next time. Bye bye.